Okay, yesterday I forgot to explain you the buffer flow, DDoS and all everything I have explained you guys. But yesterday means sorry for the last class. Today we'll be discussing about some part of like buffer flow to an extent whatever it is required for you. You need not to be a programmer or anything for this. Just remember like you have some memory, say for example RAM, and a program is running. When you have some program is running, okay, in the RAM, it is allocated with some certain amount of information to be processed means you will be allotted with some space. Let me show you in the, let me show you here the paint. Okay, don't save it, cancel it, new, don't save it. Okay, so say for example, you have RAM, okay. As soon as when you click any program that is available in your machine, I say program means it can be an application, or it can be a source code what you have written, or it can be some kind of any a file which is helpful for your operating system. Anything is nothing but a program. Okay, internally the code has to be executed. So internal code has to be executed. So when that comes, first it has to come to the memory. That is random access memory. Example I'm just giving here. Okay, and when it comes here, the RAM will allot some information to it. I mean, like some space to it, like variables you can store here, and you can say for example, the execution methods and all can store here, and some other functions can store here, or some other classes can be stored here. That kind of some allocation is there. So, and also you will be having some kind of buffer space will be there, okay, for your program, and some other program related specific data will also be there. So like this, every multiple programs will have different kinds of programming, and it will have some kind of allotment. So you might be like running multiple systems, or like 1,000 programs means you'll be like running at the same time in the like from the RAM, it will be allocated some memory, and they will go and get executed in the processor. Okay, your system. Okay, and the program is stored in the hard disk. When you say it, it will be loaded into the RAM, and from there it will be sent to the processing. Okay, so now the malicious users, what they do is, what you know that this is your programming space. Okay, instead what they will do, they will like if it is 10 kilobytes, okay, of the programming, what like the variable length is, if it is like say for example here each variable is 10 kilobyte, okay, a specific variable or 10 bits, okay. What intentionally does is like he will be sending 200 bit of data over there, okay. So what you're doing, the space here for in each variable is 10 bit, okay, 1 2 3 4 5 6 7 8 9 10, so okay, something like that. You are overflowing with lot of other information into that particular thing. So since if the programming if there is whatever the whoever is like doing some sort of, what do you say, the programmers who are developing any applications, if they are not controlling this kind of things, okay, if they are not fixing this kind of bugs, like not to allow greater length of variables getting inserted over there or something like that. So what you're doing is he might be like allowing it to exceed it, and internally some other parts of the code which is having sensitive information, you can access that memory also. So the overflow is let us to gain access for some other memory locations, okay, which we can see some sensitive informations somewhere, like the addresses of the sensitive informations. So later point of time, what you can do is you can actually like write the normal 10-bit program, but when you are accessing some data, you'll be accessing some other part of memory addresses which you have read during the buffer overflow attack. Is it clear? Is it clear? You want me to
Yeah,
explain once again? It's clear, right?
clear,
See
yeah,
what he
clear.
has done. Like, yeah, something data is there. This is the part of the location which it has to be stored. But instead, he has flooded all different kind of data in entire thing. So now he has come to know that where is saved EBP or saved EIP or stored. I'm just giving some. I don't know what it is. Some other private data locations. Okay, those informations also addresses he has come to know. Then later point of time he can use those addresses for other programs, others programs also, or he can able to access some private data what is running over there. Okay, so that is kind of that is one that is called as what I can say buffer overflow attack. If someone asks you, tell this much, that is enough. Um, everyone, is it comfortable for you guys? Buffer overflow attack?
Yes, yes,
Everyone.
kind of, yeah, kind of. Yeah, but if
Okay.
is there any text? Hello, hello.
Yeah, go ahead. Yeah.
Yeah, it's Francis.
Yeah, Francis, go ahead.
Yeah, these topics are they in? Do you have any kind of book, like the kind of book you gave the last time?
No, 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 no. These things, even I will suggest you not to get into too much of these things
Okay,
also
okay,
for
just like
us.
a necessary
Yes,
knowledge
just the
for.
glance.
Okay,
Yes, just a
okay,
glance.
I get you. I
Because,
get you. Yeah.
yeah, yeah, sometimes during your investigations, maybe at least someone using that particular word, you should be able to aware of it. Okay?
Oh,
But
all right. Or just
usually during the interviews, they ask these questions. Okay?
okay. That's
Fine.
okay. So the videos should be okay.
Yes, yes, yes. This is
All
enough.
right.
Yeah.
No worries.
Okay. Okay, now, as I said, the initial encryption algorithms from the 50s or 60s, you can say it as like the DES, okay, for encryption. What it is, okay, take the plain text, whatever you have, insert some kind of 56 bit random key, and get some output out of it. So that is called as digital encryption standards. Okay, just nothing. You have some kind of 56-bit key, okay, and what you have done is uh, it is like just take plain text, 56-bit key, give it to it with that TS some mechanism algorithm, okay, and then you will get the ciphertext. And the ciphertext receiver receives it, applies the same DES algorithm to this whatever the text he has received, and this is also 56, same key, whatever it is, and converts it into cipher. But to be frank, this is not so, what do you say, useful for anyone because they were able to easily crack those passwords, DS passwords, when the computers are getting evolved. Okay, so they moved to something called as what do you say, triple DES. Okay, what in triple DES they do is simple way. I'll show you. Okay, now you know how it works. Okay, take the plain text. Okay, okay. Now key one you take, which is 56 bit. Okay, and use the algorithm and convert it into ciphertext. Okay, algorithm like DES algorithm only you will take. Okay, and send it to the next module within the same machine itself. Next module which does the within the same the ciphering program itself. The next module it takes okay E2 E2 and what it does is applies decryption. decryption, not encryption, decryption. Okay, you will get altogether different key. You won't get the same key, same plain text. You won't get it because the key is wrong. So you will get some more ciphertext. Okay, then what you will get? You will send it to the next. Okay, there key 3 they will take it. Okay, and they will apply, okay, decryption of this particular thing with key 3, and they will get one more cipher. So they will take it in the reverse order. They will be applying the same key each and every location, so that they use the key 3 here to decrypt. They will get this information, and they will apply uh, this key here so that they will get this information. And you got here some whatever the text it was generated here. Okay, and they will apply again this key here so that they will get the cipher. And once after applying this main key, they will get the plain text. This is called as triple TLS. DS algorithm only 3 times have applied. Correct, right? 3 times have applied. In reverse order, they did the decryption. That's it. Is it clear or not? You want me to explain once again, guys? Am I a little bit fast today?
Yeah, once explain, please.
Okay, once I'll explain. Okay, fine. Don't worry. You have the plain text. Okay. Now, okay. Now, here I'll be applying something. Okay. What I'll be doing? I'll be applying DES algorithm. Okay. Got it? Okay. With a key 1. What I'll get here? Output is what I'll get. Cipher, right? Till here, is it clear? Okay.
Yes,
now,
yes.
Okay. Now, send this. Now, in the second stage, use DES itself. But what you'll do is use key 2. Okay. Means one more 64-bit. Okay. And try to, means you are using the wrong key. And trying to decipher the text. You apply decipher text. What happens? Some other gibberish data you will get it. Correct, right? That is cipher text. Some other gibberish data you will get. What you have done, instead of encrypting with the key 2, what you have done? You have done decryption. Okay. So that you will get some more complicated cipher text you will get. Okay. Then what you will do? Again, you apply DES. Okay. With key 3. Okay. Which is also wrong key. Wrong key means some 3 keys you have. I'm telling it won't provide you plain text if you decrypt. That's the reason. The operation itself you are doing is wrong. What you have done is you applied it. You will get cipher text again, because what you are doing here, decrypt, encrypt. Okay, now you got a strong ciphertext, right? You got it or not? Okay, now this is sent to the receiver. Okay, now from here receiver side we will see. Okay, receiver has taken it up. Okay, receiver has taken it up. Okay, now what if he does? He will get the, what if he does? He will get this data. He will apply key 3. First he will apply key 3. Okay. Then next step he will get key 2 data. I mean like second stage data he will get. And then he will apply key 2 so that he will get first stage data. Then he will give it to the first stage. He will apply the whatever the key he has applied, key 1, he will get the plain text. Just remember till here. 3 times it will be encrypted. That much you remember. Okay. If you are not understanding, I have given what do you say? I will give some other links if someone wants to go through it. But now you just remember till here. Like you will be applying triple the times the key applied 3 times so that you get a strong ciphertext. But the receiver, whoever it is there, has to apply those keys again to get the plain text. Got it? Triple DES applied 3 times. You got some ciphertext, again apply ciphertext, again applied ciphertext. So 3 times you have done it. Is it okay?
Yeah.
Yeah.
Okay. And they say it is like 96-bit, 192-bit. I think Francis, there is some noise coming. Okay.
I just
Yeah.
mute it.
Yeah. Okay. So 56. How much it is? 168. How much? Correct, right? 168 only.
Yes.
Okay. So yeah, 168. Yeah. They say it is 168-bit, but it is wrong. To be frank, it is like just 56-bit key only, but they say like it is 128-bit, 168-bit password protection you get. No, the same 56-bit. If they come to know the 3 keys, they can easily crack it. Okay. So that is about the triple DES. Okay. No one will use it nowadays. Even if you find somewhere in the certificates or some kind of locations, you just immediately tell them that to use the control over there by removing those things. Okay. And now mostly we use these advanced encryption standards, AES. Okay. I'll show you in some time how it looks and this thing. It will be just like you take a block of, okay, if you have a file, take the block of code and apply this AES, and you will get like based on like different 128-bit data or like 192 or 256. Okay, take like whichever it is, the size. But if you take 192, 126 means like 126 bit of data, sequentially data, you will be taking that particular amount of data and you will be applying some algorithm and converting it into the ciphertext. Okay. Okay.
This is in block cipher,
This is
right?
in the block. Yes. Correct. Okay. So you don't require all these things. Okay. Not to get confused. This is the modern sulfur. I mean, sorry, not sulfur, cipher, which we are using. Which we have gone through, right? You will be applying for the certain amount of data you will take, and you apply some encryption, which we have seen it in the. So the block can be like
So
any
now we are
block, but
using block.
yeah, everyone is using block only now. AES
Okay.
itself, it is
And
kind of, yeah. You take
where the
what do you
stream cipher is being used?
nowadays no one is using stream cipher.
Okay.
Okay, so means like you can like the any kind of encryption you can take it, but it's like more suggested for you to have which is little faster and more secure. Okay, so the
Right.
key size can be 128, 192, and this thing. Okay, I think these things are there. Okay,
And one more thing,
let me,
Raghav, are the sizes of the
yeah.
blocks fixed? Like
No, it
what's will be
is,
the size?
okay, let me show you that here. Oh, online encrypt. Yeah, well, let me check. No, this one I don't want. Is there anywhere I can select? Okay, see, I can select some algorithm. Okay, any one algorithm. Okay, okay, you take, this is a old. Okay, triple des is there, des is there, or you can, the size, it you can have anything, but I'm just trying to get some uh, very good easy example for you, like we can immediately get into it.
So there is no standard size, like this will be the size of the block. You can choose according to your.
No, 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 no. It is like you are this guy, your encryption, wherever it is, who initiates, right? What is the ciphering mechanism we will follow? That's what you'll come to know about it in some time. Okay. So in certificate, I will show you the, what do you say, if they select any algorithm, okay, then they will follow different kind of locking mechanism or something like that. Okay. So if it is like 128 bit means it will take 128 bit and it applies 128 bit key and performs that particular block size thing. Okay. So it takes 128 means you will have 128 bit key. Okay. It takes 128, then next 128, next 128, then converting it. Okay. So this is the advanced AES standard. Okay. Um, you can there is some tool I will give you. Um, okay, I can, but I don't want to pull you guys into this immediately now. Later, after finishing, maybe tomorrow, when we do some hands-on, I'll be showing you these things. Okay. Today also we'll do, but to certain extent, some kind of reconnaissance, all those things only we will do. Okay. Reconnaissance means like some hands-on tools for reconnaissance or footprinting related thing. Okay. So there is something called as security. Why we are looking for the security of the website? To make sure, like for having the secure communication between you who is sending the data and the me who is receiving. If I'm sending some data back to you, that data should be more secure. That is our intention. So for that, what we are doing, we are using the ciphering, the converting the plain text, whatever I know, like human understandable language, into some kind of ciphertext, which is most of it will be this gibberish, right? Okay. So how you are going to do? You are going to use some kind of algorithms. As I said, we have discussed like DES, okay, AES, okay, triple DS. All these things are like some algorithms. Okay, so usually how you can share that particular key is like, oh boss, I'm just communicating with you in this particular format, and you tell me like how, what and all you can understand. So this is my information to you. So all those things are called as you're binding it in some kind of certificate, and you are sharing it to the other system that, okay, if you want to communicate with me, okay, see, this is what uh, the keys that you have to use. I'll show you. Just remember that a certificate is the information that contains all, say, for example, the communication. If you are establishing with me, I want to have a secure communication with you. So I'll be sending the certificate to you saying that these are the things, security algorithms I can support. You choose yourself whatever you want, and I'll be sharing my public key with you. When you are encrypting, sending the data to me, you please encrypt that data using that particular public key and send it to me, and I will be able to decrypt. Even if others captures in between that particular data, and if they try to decrypt it using the same public key, but it will not turn out to be the same plain text, because the only thing which converts that whatever the cipher text into the plain text is the private key of the receiver. Am I correct? This is what we discussed, right? Last time, guys.
Yeah, it's
Again,
right.
some confusion. This okay. Let me show you. Okay. See, I am sending some data, and I would like to have a communication with you. But this person said, no, 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 I won't let you to communicate with me in plain text. I don't let that happen. See, you might be like kind of very adamant to the, I mean, like for the security issues, but I am very much strict in this. So he will tell, if you want to communicate, certificate, you'll be sending it to him. In that certificate, you'll be sending some information related to all, like what kind of ciphering algorithms you will support, and your public key, okay, and some other like your some server related information, like your organization information, like whether this guy is valid or not, that kind of, because you cannot blindly trust everyone who is sending data to you, right, with some certificate. So please, if you want, you can verify me, and you can use my public key, and use any of these algorithms which I can support. So this guy, what he'll do, he'll choose one algorithm out of the list of algorithms and chooses, takes the public key, and whatever the plain text is there, right? Okay, he will, this is public key, and he'll apply that on choosing some algorithm, and takes the public key and applies it on the text, and it will become the cipher text, and he will send it to this person. Okay, okay, and this cipher text, whatever it is received by this particular person, since he knows some middle in the, if someone in the middle, if they captures it, until and unless if you apply the private key of the receiver, okay, private key of the receiver, okay, receiver, private key, okay, you cannot convert into the plain text, okay, but if you apply, since you have the public key, if you apply it, you will get the cipher text back again, some other gibberish text, you will get it. Okay, so that's why receiver, what he'll do, as soon as when he gets the data, he will apply the private key of the server, so he will get the plain text. Is it clear now,
And
guys?
how do we obtain
Yeah,
the private key?
okay, I will, okay, for your sake, let me show you. uh, there is a software called as OpenSSL. Okay, you can create public and private keys. Okay,
Okay.
uh,
Okay.
I kept it here. Just OpenSSL help, if you help, HELPA. I don't know. Okay, it is only this much. Okay, you get lot of commands here, like which and all algorithms you can create, whether you can create certificate, or you can encrypt anything, or so many commands are there. Okay, you can do a lot of commands. Let me check. I have few commands. Uh, think I have run some commands. Okay, take this particular thing. I want to triple DS I have taken, algorithm I have taken, and I'm generating a key, which is a private key, okay, for my sake, okay. So for example, okay, and the key length should be like, say, for example, 1020 something I have given, the key length, okay. So this is the key, whatever I have, okay, OpenSSL, generate triple DS algorithm. I'm using algorithm from RSA for generating triple DS is the algorithm I have used, and uh, the service I'm taking from the RSA side. I'm just generating some algorithm. Okay, and what I'm doing is I want output, okay, as private key, like some key I want it. Let me take it. Okay, it is asking me to for a secret for you, which is you only alone know. So, okay, okay. Now, uh, okay, sorry, I have done some error. Okay, test 1 2 3, test 1 2 3. Okay, now, so something private one key is there. Okay, if you go here, ls if I do, okay, private one key, private one key is there. Yeah, private one key is there. Have you seen this, guys? So this is a key which is
Yes.
generated. Okay, cat, okay, private uh, one dot key. Okay, this is the key. Okay, you should be keeping it very securely. If this goes out to some attacker, he can generate, okay, he can generate his own this kind of things. And if he is a man in the middle attack, he will take all the data, whatever you are sending. Like if HDFC Bank's private key, if you get it, okay, then they will be able to decrypt any kind of data. That's why they will keep it very securely. In real hard shelves, they'll be keeping it. In real hard copy, they'll be securing it in some location. They don't put it in the normal this thing. A copy of it will be securely kept it in separately. What it is that? That is test at the rate something test 1 2 3 I have given, right? That particular text they will be securely keeping it in some location. Okay, because if attacker gets that particular information or this particular information, the key or the phrase what you have used, password phrase you use, it is like it can be like maybe not today, maybe within 1 week they can easily crack it. Okay, so you got the private key. For all the data, whatever you will be receiving on your machine, okay, to decrypt it, you can use the private key. But you have to share some key to the entire external world, right? For that, what you need? You want public key, correct, right? To the external world to share what you need a public key. How you can generate? Just use the same uh, yeah, RSA, okay? You are giving private key as input and generating public key as output. So private key 1 you are giving and getting public key 1. Okay, just take it. Let us see. And now it will ask for you. Okay, was excellent. You are asking me to provide a public key. Okay, but until unless if you are an authorized person, I don't let you to generate the public key itself. So for that, what you will do is you will give the same passphrase, whatever you've given over there. If I give something wrong password or anything, it won't generate. So enter the
So we are
password phrase.
generating the public key for the private key that we have generated.
Yes, perfect. Correct. Using that particular private key, you are generating the public key. Correct, right? Okay. So now you see cat.
Saraga, one thing, please.
Yeah. Hmm. Go
So,
ahead.
like, first of all, we have generated. Let me just clarify
Hmm.
it for
Okay.
myself.
Summarize. I'll put
Like,
it in the points. Wait. I'll put it in the points for you. You just explain whatever you want, but I'll put it in the points.
sure.
Okay.
So I'm
Just
saying
tell
like
me now. First point. Yeah.
you have taken the plain
Yeah.
text. Okay.
Yes.
Then you encrypted it
No. For
using
now, we
the.
are just generating the keys. We are just generating the keys. We are not doing any encryption yet. We need keys, right? First for do anything, public and
Okay, but
private keys.
actually, I was just asking like how those keys will be used for encryption, the mechanism.
Okay, that's what I'm telling. So before sender is here, he is having some plain text. Okay,
Okay, right,
receiver
right.
is here. He is having some. He has to understand that. So sender has given received before you do some like some certificate exchange happened, and during the certificate exchange public key is sent to this particular thing, this guy, and he has also told this guy that I am using so and so algorithm. Okay, and he has told like public key, and these are the algorithms I can support: algo 1, algo 2, algorithm 3. Okay, now he has received it and he has chosen one algorithm, and this guy sent some that public key. He has taken the public key. Okay, and then both the things you have taken it, and you have converted into some ciphertext, and that ciphertext you have sent here. Now the key whatever you have sent for him to encrypt is the public key, correct? Am I correct?
Okay, okay.
Okay, now someone in the middle, if he captures this data, okay, uh, Francis, could you please go on mute? Yeah, some noise is coming. Okay, so the plain text, whatever to extract it, you need to have public key. You need to have private key. Okay, so if you apply public key itself, again it will be the text. It whatever it gives is like ciphertext only, some different text. Okay, you cannot decrypt it with what do you say? Uh, the public key what this guy has actually shared that's why you have two keys. Until unless if you have private key, you cannot extract it. So you don't have private key. So you again got ciphertext for the man in the middle. But if it received at the other end, what he'll do, he knows his own private key and he knows which algorithm to apply, and he will apply it on the text, and he will be extracting the plain text. So
So,
private
like in a
key
layman
and
term,
algorithm, yeah, and text, whatever the cipher text, you will get the plain text. Okay, now you tell me.
so in a layman term, like we're using a different key to lock and using a
Yes,
different key to unlock.
perfect. That's what it is. Two keys. It is not a symmetric. It is an asymmetric. Correct, right? It is an asymmetric.
Okay, 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 okay.
Okay. So, so you got this will be the public key. Okay. We'll see tomorrow this small examples. I just want to show you how a public key is generated and how a private key is generated as of now. We will see the encryption like plain text giving and then converting it into something. But for today's certificates also, I will show you how to create a certificate. All those such information I'll be able to show you, but just bear with me for today on knowing how um, like the implementation happens, like what and all information you will be keeping aside for making this security happen. Is this clear? Public key, private key? Everyone say yes by unmuting.
Yes, Raghu.
Yes.
Yes,
Okay,
Raghu.
fine, fantastic. Okay, so now we need certificates, correct, right? Okay, why we need certificate? Because certificate will help you like to tell them the information that whatever the other system, how in which communication mode securely you can communicate with the other person. Okay, so that is one thing, and you will get like once after like getting to know like which kind of algorithms, all those things for like whether the right person is communicating with me or not, also the server will come to know. Okay, and nowadays all e-commerce websites they use these certificates. Just remember that HTTPS is a kind of the basic algorithm that is like nowadays without that no internet at all, that kind of thing, because for the confidentiality, okay, of the data, so that you can encrypt the data and you can send it to the other machine. And moreover, like you can like this will repudiation, non-repudiation, sorry, means like something you have done means you cannot deny it. Okay, so simple example, you sent some 10 rupees of data to me and I have received it, and I cannot say that 10 rupee I haven't received it, because it is clearly showing in your phone that uh, you have what do you say, sent 10 rupees to my account in your bank statement. So that kind of like recording the things that the communication has happened, for that also it will be used. And it will be like not everyone, like whatever the public key I have generated, uh, all that thing is for my self certification. Okay, okay, self certification, which is not useful for like public like my browser. If I give if I try to upload my certificate here, like here, mm, settings, yeah, certificate, yeah, security, yeah, there anywhere certificate where it is here. Okay. So these are the issuing authorities. They will be only having the power to provide. If you are an organization, you should get the public and private keys to be generated from their side. And once if they generate, okay, then you can use at your system, okay. And these keys will be generated by them only, right? So like whatever, like you when you buy it or when you buy some certificate. Now see, I have used I have some small tool. What is that? Let me show you. Yeah. See, SSL scan. Okay, is that tool? Okay, means like some which kind of certificates they are using, that kind of scanning they will do. And I am trying for elearninfosec.com. Okay, and it gives me some information that what algorithms I can support for encryption. Okay, this is my algorithm, which is like signature algorithm, uh, ECDSA. Okay, some my signature, whatever I have, uh, all those things, and it will give me like which port I am communicating. Okay, usually 4443. Okay, um, like secure session renegotiation supported. Compression, I have disabled it. Okay, and I'm not vulnerable for heartbleed or such and certain kind of information it is giving. And if you see this particular part, who is my certificate provider?
Cloudflare.
SSL certificate, I have bought it from
Cloudflare.
Cloudflare. Cloudflare, I have bought it. If you want, I can show you. Let me show you. Cloudflare. Okay. I think I should be able to log in. Okay. Oh, God. Okay. So this is a website, and I have used the SSL certificate from this guy. Okay. And is in full this thing, and I can see that I'm on what do you say, kind of some customers they are asking me using I'm not supporting SSLs, I'll be supporting only TLS. We'll see what is SSL and TLS, and other parts like TLS 1.2, 1.3 and all we'll see later. But as of now, what is meant by SSL and what is meant by TLS, we'll be seeing it. But I'm using some Cloudflare related service for my like secure communication. Okay, I am using Cloudflare service for my secure communication. Okay, so Cloudflare is given me some certificate. Okay, if someone wants to communicate with my website, Cloudflare has given me certificate. Whoever enters my URL, I'll be throwing my certificate to them. Let me show you. Open this. Okay. Okay. Let me start. Continue. Okay, just let it be. I'll be trying to send some data from here. That is uh, learn infosec. If you see this, some kind of data you will be seeing here. Yeah, yeah, yeah. So there is some kind of data. If you see here, okay, my system, whatever it is there. Okay, let me check this. 172.67. Yeah, this is the one. Let me just get the host name, whatever it is here, what it is there. Host elearn infosec.com. Yeah, 172.67.200.150. Okay, let me check. Okay, this one. Okay, if you see this, guys, if you see this, okay, is this the elearn infosec web server? Am I correct, guys?
Yes, yes.
Okay, so this server is here. Okay, and what I am trying to do, I am just trying to, where it went over. Where did I, Wireshark, right? Okay, forget. So 200. 150 is the location where I am trying to send. Okay, let me check IP address. IP address is equal to filter the specific IP address traffic, just give like this. Okay, 172.67.200.150. Just give that information. You will get all the traffic from here, pakka filtered for you. Okay, so now first for any request, this is an important interview question. Please go through it clearly. Okay, if you have any questions, I am happy to repeat it 100 times. Very simple, just understand it as like a story. Okay, let me open this. Okay, new. I have a web page. I would like to establish a connection. I would like to get a web page. What is the request from this client to server I'll be sending? Usually, what is the request I'll be sending? Initially, I just want to have a communication to be established with this server. What is the request I'll be sending? Tell me. Guys, that's why we have to go through it. Okay, you will be sending SYN request. Correct, right? For establishing, this is a client and this is a server. Correct, right? You will be sending a SYN request.
Yes, yes.
Correct, right?
Yeah.
Okay. First, you have sent a SYN. Correct, right? From your 192.168 to that eLearn-InfoSec system. Got it? You have sent it. Super. Okay. You have sent the request. Okay. And if you see here, transport. Okay. Flags. You have something called as SYN flag is enabled. Have you seen this? But remaining all other flags are 0. So this is a SYN request. Okay. SYN request, you sent it. Okay. From the server 172.67.200 to this, it told that excellent boss. Okay. Good, you have come to me. Okay. Now I'm acknowledging that you are asking me to communicate with me. For that, what I'm doing is I'm sending you SYN-ACK. Okay. And this server will send that, oh, your request is received. Your request is received. Okay. As I said, the sequence number, acknowledgement, what happens, you have to see in that TCP. Because you are establishing the connection. Majority of the work will be transport layer work. Which protocol is used here?
TCP
Transport
UDP.
layer. No, only TCP. Don't
Okay.
tell that TCP UDP. Only TCP.
Okay.
It is a connection oriented. So TCP
Yeah.
only used. Okay.
Okay.
Got it? Okay. Have you found that or not here? SYN-ACK. Correct, right? If you see here in the flags, you have SYN bit enabled and SYN bit enabled, SYN is set and ACK is set. Got it? Now, this is the SYN-ACK which you received from the server. SYN-ACK is received from the server. Next, client, for making the connection with the server, what you will do, client? Client will be sending acknowledgement. Correct, right? Saying, boss, whatever your SYN-ACK you sent, I have received. Let's please start transferring the data to me. I would like to have. Allow me to communicate with you. Okay. So you have sent acknowledgement. Okay. Let us see, it isn't here. Okay. Go here. Okay. The acknowledgement, you have received it. Guys, I have clearly told you. Just go through packet level very carefully. What's happening with SYN, SYN-ACK, ACK, what's happening with acknowledgement number and sequence number. Practice them. You will become expert in the area of like analysis. Okay.
Okay.
Important it is. Okay. So next, okay, fantastic. Server has received the this thing. Okay. Then immediately you told that, okay, server has received it. I would like to see acknowledgement. I'm sending some data. Now client only has sent, okay, hey, please, I would like to have some communication with you. Okay. So client has actually what it has done. It has sent some hello message. Okay. Some hello message it has sent saying that, boss, I would like to have some communication with you. Okay. So client send client hello. Okay. With some all its possible ciphering keys, all these things it will be sending. Okay. See, all this information will be there in the certificate. Okay. See, if you see this, not only the server client also supports some algorithms. Server also supports algorithm. Client send, okay, earlier our machine has sent some information like the similar kind of, okay, algorithms. Okay, client has sent it to him. Okay, to whom? Server. Client is telling to the server that I would like to have some connection now securely. So that is called as TLS. Now let's get back. What is this TLS? Okay, in 1995, before to that 95, okay, everything communication was happening over the internet is plain text. Arams, if you have any bank account, okay, if you are like very good at hacking, you would have made millions during that particular time because you can actually like take the plain text and do whatever you want and like can be do anything. There is no encryption, nothing. Did I said the story about the uh, Netscape? I think I've told right Netscape story, Netscape Navigator, Mozilla. Correct, right? They are the first into the business of browser. So the burden of creating the secure browser was on them. Okay, so they have come up with SSL 1, okay, version 1, but unfortunately they didn't release it into the open market. But they have released SSL 2 version 2. Version 2 they have released it, but it had lot of flaws. Okay. Then after some time, 1996, they have released SSL 3. Okay. So when you do perform scanning, it can be in SS scan or it can be any other scans, means scanning the systems which 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 their applications, what algorithms they are supporting. Okay, how they come to know means like looking at the certificate, like the certificate, what algorithms they'll be supporting, version TLS, okay, like this. Okay, if any server or client or something, any machine, if it is telling that they are supporting SSL 2, immediately you have to stop that service. First thing, you should not let that service to be enabled on any server or any machine because this is more vulnerable. Okay, that particular thing has got a lot of weakness, means the password can be easily cracked, just it requires a very good powerful machine. All those keys, public and private keys, can be easily cracked. Okay, so that's why SSL 1 and SSL 2 are like should not be there in your organization. SSL 3 is the new version, and they named instead of SSL 3, they said it as TLS. They named it as what? TLS. Transport Layer Security. It is not Secured Socket Link Layer only. Okay, secured. I think SSL means that only, I guess. Okay, so SSL v3 is called as TLS. Remember that there is nothing in difference. oh, TLS means something else or nothing like that. It is SSL only, but they renamed it as SSL version 3 to TLS. Is it till here? Is it okay, this story? Have you understood this story? This part?
Oh, yes, sir.
Okay. Now you have understood this part. Okay. Now you come to know that SSL and TLS are there. Okay. SSL itself version 3 is TLS. Okay. Now what you are telling is, I would like to have communication with you. Boss, please help me out. I know these ciphering algorithms and all these things you have told. Okay. Then it said an acknowledgement with that saying, oh, that's an excellent that you would like to have communication with me. I have received it. Okay. But whatever you say, I don't listen. Okay. Whatever you say, I don't listen. Okay. What I'll do is I'll be sending you, okay, some sort of information how to communicate with me. Some sort of information how to communicate. Based on that, we will communicate. Not you, a small client, cannot tell me what I have to do, how I have to communicate. So immediately server, what it will do? Take this and throws it in front of the server. Take this. This is the server. This is the what do you say? Things I'm sending it to you. Okay. So it will have all different kinds of information. That is like what and all. That some key it will be shared, public key. Okay. And what kind of algorithms it will be supporting. That is like AES algorithm it is telling. Okay. Now you choose whatever you want. Okay. And just let me know that. Okay. Now the server actually sent that particular keys to this public to this particular machine. Okay. This is like if you have extra data on that, it will be encrypting and sending it, okay, to the other system just in case. Okay. So now the client has received it, right? Now what he'll do, he will open it and he will say that, boss, whichever you sent, thanks for that. Okay. If any data for this application data, it will be sending. Okay. So now you see this, the client takes that and the server told some cipher to use. What cipher it told to use? If you clearly go here, where it is cipher name, anywhere it is there, just, okay, this one. Just use this particular cipher. Okay, this algorithm you have to use and use my key, public key. Okay, use my public key. Okay, and use this particular algorithm. Yeah, I know that you know a lot many things, but I'm least bothered about you know so many things. But I am telling you what to use. Okay, use this particular thing. Okay, and server when it said that, okay, the client said, okay, I am using that whatever you're told. Okay, and I am sending some data to you by encrypting that particular public key and sending it to you. Okay, and this will start the communication like the application data will be encrypted again and will be sent using the same thing. They both communicate using the agreed upon the keys. Okay, so every time when the client sends some data, it takes the server told the algorithm, that is the encryption algorithm, and the public key what it has shared with us. So the text data whatever you are sending over there will be putting that information over there into that particular algorithm, and using that particular key will be running it and will be sending it, so that all the data will be in encrypted format. Okay, if you see this application data, it is in encrypted application data, encrypted application. So no one can actually decrypt it unless the server side, it takes this application data and converts it into plain text by applying the same algorithm, and instead of using the public key, it puts its own server private key. Is it clear now? Silent, so many people. Who?
Can you explain again?
Okay, let me take. First of all, to an HTTPS communication to be established, I have given HTTPS elearn info sec.com. Okay, this is the URL I have typed. Immediately in the browser, what it does, it performs a DNS query and gets the IP address. What is the IP address of the system? This is the IP address of this system. Where it went? Yeah, this is the IP address of this system. Which system? The elearn infosec website. Okay, elearn infosec website. Okay, just copy that. Okay. Web server, I should say, instead of website. So now you just put it here. The DNS query you have done and you have got this. Now you have to do communication in between whom? The client and the server. This is the server and this is the client. What is the client? Client is our machine, correct, right? Our browser, correct, right?
Yes. Yeah.
So what is its IP address? 192.168.1.2. Is that correct? Our machine's IP address is that only, right? 1.2. Okay, if you have doubt, go CMD. Okay, IP config. Okay, you got it. 192.168. That wireless LAN I've connected, and it's my system's IP address is this. Okay, now this is the client and this is the server. Now let's start communication. Okay. Okay, both have to do. Before you connection, for any system you have to connect means, what is the first message you have to send? Okay, you want to send some data, but first thing what you have to send? First what you should establish? Connection, right? Transport layer connection you have to establish, correct, right? Okay, so first what you will do is, you will be establishing three-way handshaking, correct, right? Let me change it to different color. Okay, this is the three-way handshaking. Ready. Three-way handshake. Important, I'm including like certificate and three-way handshaking, so that interviewer, if you explain like this, you will be more like happy that, okay, you know what is happening before and you know what is happening after also. So better you also follow the similar kind of procedure when you are explaining it to the interviewer. Okay, so three-way handshaking. Three-way handshaking means first you will be sending SYN, correct, right? And you will be receiving SYN-ACK, all that process, correct, right? Then you will be sending ACK. So that process is completed now. Okay, I don't want to explain that thing here again. Correct, right? That process is completed. Correct, right? Now it is the connection is established in between you and the server. Now you both can start. The transport layer is established. Okay. Now next what you will do? You will be sending you want to establish secure connection. The connection is established. So you are asking it HTTPS connection you want to send, right? So what you will do is, hey boss, I would like to have a secure communication with you. Okay, you will be, because you only said HTTPS. Did you, correct, right? You only said, right, HTTPS. Who sent HTTPS?
Client.
HTTPS message who has sent? Client. In his browser, he has entered. So it is like, I want hello. Client sends hello message. Okay, it's better to write like this, man. It will be more clear for you. Client hello. Okay, client sent some hello. Okay, with what information? Hey boss, I would like to have some communication with you, and I want to tell you that I know some algorithms, okay, which I can understand, okay, like supporting secure algorithms. And that is meant for what algorithms are used for? Encryption. Correct, right? Correct,
Yes.
right? Okay, you have sent them. Okay, now see this. Now, client has sent all this in SYNAC, everything. In between, whatever you're seeing is some kind of connection is still active for that particular thing. These messages you'll see, like for like ACK, all these things. That client you have sent a request and server says that, oh boss, I have received your data for that purpose. Okay, client has sent some request. Okay, saying that, okay, boss, I would like to have a communication with you. Okay. And remember, this is HTTPS, right? 443 is the destination port. Source port can be anything. Okay.
Okay.
And you will be telling that I would like to have some security, like SSL handshake now. The normal transport handshake is happened. Now I would like to like the secure transmission should happen in between you and me. The data should get encrypted. So that handshake we will start. For that, I'll be extending my hand for you for a client hello. Okay, that is the client hello. Okay, now that is the first thing you will say. What you are telling in that, okay, boss, I'll be supporting these ciphering algorithms. That is the main thing. Okay, these ciphering algorithms, I'll be ciphering suits, you should say. Okay, I'll be able to support. Okay, and remaining rest all information you forget. Okay, and the client, as soon as when it receives this particular client hello, it will send some acknowledgement. Okay, but all those things, minor things, I'm not including here. Just server sends some acknowledgement that I have received your hello request. And after some time, what it does is server, okay, that's very good. You want to have a communication with me, okay, but you have to follow whatever I say, because if you want to communicate with me, you have to follow my way of communication. Okay, my way of communication. What it said in my way of communication. If you go and see here, server said hello, server hello, server hello. Okay, you know lot many things. Okay, you know lot many things. Okay, but tell you, I would tell you to use. Okay, where is it? Where is it? Okay, okay. TLS AES 128. Okay, just go here. Here it is 128. Okay, 1 second. Where it? Okay, okay, okay. Maybe this might be this one. Okay, GM. Okay, wait, it is GCM is short to 56. Yeah, this one. This is the one which it has sent, the server sent for that particular moment. Okay, this particular algorithm it has sent. Means like when we did the scanning of that SSL, right, we got this information. I'm just showing you. Okay, it has got lot many things, but still it said to use this particular algorithm, say example I'm just giving. I think it is different. Okay, something which it has the server has sent. Okay, now this algorithm and use this particular key for all your transactions. For all your transactions, whenever you are use this algorithm and use this key, which is a length of uh, 32-bit length. Okay, use this particular key. Okay, now what it is doing is, okay, the length is like the number of these things, I guess. Okay, let it be. The key is that has stored and shared, and it has shared the algorithm what it has to use. Okay, the server has told it has told us two things. What it is, bear with me. After this, we'll take the break. Okay, shares cipher algorithm and algo means algorithm. Just remember that ciphering suit, I can say better, suit and public key. Okay, till here is it clear for you? First of all,
Yes,
everyone,
yes.
please.
Yes, yes.
Okay, now client has to respond some information, right? Okay, now the data, it has sent it. Okay, and then data means like if it is more means it will be sending like this. Okay, so let it be. Now this particular thing, client will sell that. Okay, whatever whichever you have sent, I have received, saying one acknowledgement that I'm not displaying it here. Okay, if this one receives any data, it has to respond some acknowledgement because it is a TCP. That is what in between you are seeing. And if it is received some data, client, it has to tell the server that, hey, we have actually received some data from you, some acknowledgement, you will be sending it. That is this. Okay, but now we are only noting down only the major main things. Okay, this is here the next major thing, the handshake related messages. Okay, then what it tells is, okay, boss, I have given you list of things, right? Before my asking you, before I was asking you the connection. Now for you, with you now, I would like to communicate, right? So you told me to use this algorithm and this particular public key. Okay, so I have chosen them. Okay, so if you see that I am using the same ciphering algorithm what you have told me, and I have changed the ciphering key. Okay, I'm giving you some assurance that whatever you have told, I've taken it up. Which one it has used, it is not telling, but it is telling that I have used the change, and it will put some dummy data and sends that and sends to the other machine. Okay, and then okay, this says that the algorithm has chosen and it used the same public key and using that particular algorithm. Okay, this text is sent over the TLS, means HTTPS text it has become now, and it is encrypted and it is sent now. Okay, so you sent all the data, okay, to the other machine, and it will say that, okay, I have received it. Okay, and they start communicating in between. Okay, so the last step what you have done is change cipher. That's it. You have told that I have successfully utilized and I'm encrypting that change cipher. Okay, means okay, use the same algorithm, same suit. Okay, cipher suit, And what else you have to use? Cipher suit and what you have to use?
Public key.
Yes, that is
Public.
key, which is shared key by server. Correct, right? So that is, we say it as public. Correct, right? We say it as public. Okay. Just you can say shared key by the server. That is public only. Okay. So then boss, you have received it. Okay. And it is going towards this side, right? And now they start communicating using cipher. Okay. Secure communication. Now anything, whatever in between they are doing is like for next data onwards, he'll be just sending with that. Correct. Yeah. Okay. Is it clear now? Every one of you. See, important for us being security engineers, these are important things for us. Okay. Got it? Guys?
Yeah.
Yeah.
Yeah. Okay. No problem, right? Okay. So this is the process of how your data is getting encrypted. So we'll take some break now and we'll
Bhagav,
again
one small
continue.
question. One
Yeah.
quick question. Server shares a cipher suit, right? So server has also a list of ciphers, right?
Correct.
And
And it will
client also
choose,
has
it will
a list.
choose, yeah,
How
it will
how
give you,
server is choosing which one which is given the highest priority?
I'll tell you. See, client tells that these are my capabilities. Okay. Even if you something say big, I cannot do it. Okay. So when client sent the request itself, okay, it is, yeah, the client when it sent request itself, the first thing what it has done is, please, I know this and all. In them, server also supports so many things. In that it has taken this particular thing, okay, and told that, okay, 256 at least it will be good for you. Okay, what I feel, where it is. Okay, um, okay, uh, please change your cipher to this particular thing. What it is, uh, where it went. Yeah, this particular thing. Okay, so server, whatever you given, okay, in that particular list, it's server's choice that whatever it is, the preferred or something like that, it has given. So usually by default, it will be like, uh, if you see here, it is the preferred actually. Okay, but do we get anything like this here in that list? Our requested cipher itself, it is not there. Correct, right? So it might have taken from somewhere another list of lot many supporting ciphers will be there. Here hardly I think 10 you will be received. 3, 4, 5, 6, 7, 8, 9, 10 I guess. Only 10 it will be displayed here. But you will be
Hello.
having yeah.
Hello. Yeah, I want to ask
Yeah,
a
yeah,
question.
yeah.
I mean, Parrot security, and does it work the same way as a security onion?
Palo Alto security and security
Yeah,
onion. I didn't get.
yeah. I mean, Parrot security is like is it an operating system for
No, no,
like
no, no, no,
Linux,
no.
like Kali?
Palo Alto is a
No,
equipment
parrots,
manufacturer for
parrots.
security. Huh? Parrot.
No,
Okay, you're asking. Yeah, it is like your Kali Linux. Okay, I
okay,
use
like
this.
security onions.
No, 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 no. Security Onion has got altogether different. It's a kind of what do you say? Kind of OS which is meant for like IPS, IDS activities. Okay,
Okay, yeah, malware
or like
analysis.
some signature analysis. All those things you can
Okay,
use it. But
All
this is
right.
altogether like Kali Linux machine, like your
Like
Linux
Kali.
machine.
Okay.
Yeah, like Kali. Okay.
All right. No worries.
I have a problem with my Kali, so I'm using this particular machine.
So
Okay.
it can do the same thing. So you can
Yes,
try
yes,
it
yes.
out.
You will
Okay.
have all everything here in this as well. See, like
All right. No
you can
worries.
have all like everything, all tools you have. No need to worry. Okay.
Okay. Thank you.
So yeah. So guys, let me uh, go here. Oh, I shouldn't. Let me stop